This video is a demonstration of a desktop delta, an example of which you see here on the screen. The purpose of this usually in-class demo is to allow students to watch stratigraphic sequences grow through time as base level or the water level in the tank changes. So what you see here is a 3-inch wide, 4-foot long plexiglass sided tank where you have a blue styrofoam ramp built in. Sediment is coming into the system from the left, inputted through a sediment dispersal chamber, essentially. So water and sediment are coming in from the left. They're flowing downhill to the right, where there will be, in the demonstration, a standing body of water. In order to vary that water level, you'll see the green clip on the bottom right hand of either picture is holding a tube which is connected to an outlet, so we'll vary water level by positioning the height of that tube, and it will gradually change once you change the position of the tube, because remember, how much water is in a system is a balance between the inputs and the output. This is my first time building and running one of these systems, so there's a couple of things I want you to take note of. The first thing is that the sediment supply into the system is not continuous. I'm going to just periodically be dumping sediment in, and you'll see that happening through the motion in the upper left-hand corner of the screen when we get to the demonstration. And one really cool thing when you watch the sped up version of this video is that you can watch the upstream, or the stream, quote unquote, part of the system aggrade and erode itself, and watch it try to reach a graded level as I keep adding sediment in. All right, but let's just get to it. So what you see on the screen right now is a picture of the series of sedimentary sequences that were built in this demo. On the top is just a plain picture, and on the bottom is where I sketched the sequences over the top of the photograph. Throughout this video, you'll see the sketch appear on the screen so that you can kind of reference it and watch it as these sequences build. And then at the end of the video, because we haven't had a lot of practice in class picking out and sketching contacts and stratigraphic things, I will have a very sped up version of me drawing that sketch. Full disclosure, this stuff doesn't always go well the first time, so the demo you're seeing is my second attempt at running the system. On my first attempt, I got a little ambitious with the level of my high stand and did not reinforce one side of the system. So you'll see a lot more, one side of the tank, so you'll see a lot more clamps in the demo video. But just to show you, things don't always go right. But without further ado, here's the run. Enjoy. So that's the end of the demonstration. This is just a quick video of me sketching the outline of the Delta box run you just saw. So because you won't get a chance to do this so much in any of our labs or class, when you are looking at systems like these in real life, usually in seismic, you weren't there, you have no idea what happened. These things are on the scale of kilometers. And so what you do, and what I hope you see that I'm doing, is you look for changes in the angles of stratigraphic surfaces. So essentially that on-lap, off-lap, truncation, erosional surfaces, and so on and so forth. And you sketch those surfaces, group them together, and as you do that, you will eventually begin to see stratigraphic, familiar stratigraphic shapes form. So as I zoom in and out here, you can kind of see that happening. So I'll let you finish watching the sketch, and then I'll show the picture again at the end and have a couple notes. All right, and that is our last high stand, a nice progradation surface. And just at the end here, I did a really poor job in the sketch, but what I wanted to highlight down out to the far right at the bottom is during this entire demonstration, we were accumulating silt or fine grain fraction in the deepest part of our little fake basin throughout this whole thing. So that's just what I'm trying to highlight there very poorly. Just to wrap up, here are our two pictures juxtaposed against one another. Just one thing I wanted to point out, and I try to point it out in the notes in the video, is that in the blue and the yellow, you can see our two facies that were formed during a transgression, so our retrogradational facies that are stepping back. And during the transgression, that was accumulated the blue highlighted sediment. I was adding a lot of sediment to the system, so you can see that retrogradational sequence aggraded quite a bit, while in the yellow one, I was allowing the system to cannibalize itself and not adding any sediment, and so that one did not aggrade quite so much. I also think I let the blue one go a little bit longer than I let the yellow one go for. And the other thing you might note is that not everything that was made during our demonstration was ultimately preserved. There was plenty of stuff that was eroded, which is why identifying erosional unconformities is really important. But in the end, I hope that this demonstration gave you a bit more of an intuitive sense of how base level affects the accumulation of sedimentary sequences.